the end when it's the right time, because you don't need to have it stable to write on it. It's all good. All right, let's go to question 9 that I asked you to do. How about you, Alistair? Did you get on your own?
Oh,
Yeah? So, Liam invests £6,200 for 3 years in a savings account. He gets 2.5% per annum compound interest. How much will Liam have in savings after the end of 3 years? Talk me through it.
oh, number let's see.
Okay.
Zero would be 62.
So year 0 is 6,200. And then we've got year 1, year 2, year 3, treating it like sequences. He gets 2.5% per annum, so we multiply by.
I forget what figure is by. I did 2.5.
Want to explain?
Basically, 5%.
So he gets means it's going to be increased by 2%, 2.5% every time, yeah? So we're doing 100% add 2.5%. So what does that become? 102.5%. How do we find 102.5%? Obviously, you multiply by 102.5 divided by 100. This is percentage, right? What's 102.5 divided by 100? 1.02.
I did 2 methods, and to get to 0 to 1, I found, I think, 2.5% of 6,200.
Okay, and added it on, yeah?
No,
Okay, so you found 2.5% and added it on, yeah?
Yeah,
Yeah,
but it would be times 0.2.
yeah. What's the trouble with that method? No, it doesn't work. But no, it's absolutely fine. So let's just do that. So different colour, 6,200 times 0.025 is 155. But then we have to do 6,200 plus 155, which is, and that is this number. Okay? What's the next number then? 6,355 times 0.025 is 158. It'd be slightly more, which is 0.875, so if I do 88, and then I do 6,355 plus 158 is
6,513.87.
okay. So I'm going to put that in there, 6513.88. Then for year 3, it's going to be 6513.88 times 0.025, which is
62.
let's do 85. We then do 6,513.88 plus 162.85, and we get the answer 6,676. Exactly.
0.722.
0.722. So after 3 years, yeah, is that a reasonable strategy method? Yes.
Just takes it.
So that would be my question. would you use the same approach if I said to you, how much money will he have in the bank after 25 years? What would be your limit with this method? How many years would you bother doing it for? 10? Yeah, 3 to 5. I wouldn't go much beyond 3, to be honest myself. So that's the trouble with that method. What would be a quicker method? Well, instead of multiplying by 0.025, if we multiply by 1, that's all we have to do. That does the adding. So what I can do with my method is do 6,200 times 1.025 to the power of 3. If I do that on my calculator, if you do that, what do you get?
6,676.72.
Exactly, 721. 721, okay, so just 72. So we get the same answer. All good. But which one would you use for 10, 20, 30 years? Yeah, because this one I would just change that to the number of years, yeah? Yes, because what Alistair did was he finds 2.5% by doing that, and then you have to add the 2.5% on, yeah? This, as I said, finds 102.5%, so the adding is already done. I don't need to do it, all right? Which allows me to just do times, 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 rather than times, add, times, add. There's no way, if I do the times add approach, of cutting it down. I have to do them all separately. One after the other, after the other, after the other. So by multiplying by finding the 102%, that's already doing this adding has been done up there already. All right? So my answer will be 6,676.72. So, quick and efficient, correct, but slow. Yeah. And you're right, we could say inefficient. What happens in an assessment if you're correct but slow and inefficient? You don't get to finish. So do you remember over the years you've gone, oh, but Mr. Pulse, I've not finished. What do I do if I've not finished? And I say, I live, because time is part of it. There are certain aspects where some people will be like, well, this needs a little bit more help, so we'll give you a little bit of extra time. But that's to deal with things that, you know, might need to deal with. But in terms of having a set time for each question, that's based on having the most efficient method. So regardless of how long you're given, if you do the correct and most efficient method, you get through all of the questions and you'll get them correct in that time. If you use long, slow methods for the questions, you will just run out of time. That's part of the assessment. Unless you're in another country, I think maybe it's as much time as you use. I think I've heard that past. Sweden maybe, where they're like, here's 10 questions, you've got up to 5 hours if you want to do it. Once you're done, you hand it in. So they take the time pressure off. Not in that system. All right. So that was your first question for I asked you to do. All right. Have you written stuff down? Do I need to pause while you're writing? So this one, it looks like the same, but actually what we're being asked to work out is different. So, Henry invests 4,500. interest rate, so it's a times what? It is. The times 1.05. Okay. At the end of n years. Oh. So what are we being asked to work out? How many years? So basically what we're doing is this. 4,500 is 0. Year 1 is that number times 1.05. Can you do that? 4,700. Exactly? Okay. So we know this is going up. Now what this question basically is saying is, if we go 2, 3, so on, we get to a year, n, where the number will be 5,469.78. Do you guys have a method? Yeah?
And you could estimate it in a way. 4,500 times 1.05 would probably be 4, which gets.
So, I'm going to combine both of those answers. So basically what Eden said, you could just, in your calculator, type in 4,500 times 1.05, press equals, do I get what I want? No. Do the answer times 1.05 equals, do I get what I want? No. You could just keep going. Trial and error, yeah? Now, what Alistair did though, is he's added a layer of efficiency to that, which he has estimated and said, well, I've got to get from here all the way to here, so what's a good starting point? There's no point doing all of them, so actually maybe a good starting point would be times 1.05 to the power of
4.
4, you said? And what do you get if you do that? Oh, so you went straight there? Got straight to it? Yeah. Now, obviously, we're right, so we're happy. But, obviously, we could have a situation where we don't get straight there. And we have to go, oh, I'm too big, I'll try one below. Or I'm too small, I'll try one above. It wasn't going to be many. I think that's it was a good assumption.
But what is the quickest way to do that?
So, what we were saying was, Eden started with just the beginning. She started at 4,500, worked that one out. It's too small. So we did it again, times by 1.05, found out the answer. It was too small. She did it again, times by 1.05, the answer was too small. Did it again, got the answer. She knew she'd gone as far as the fourth one. Now, Alistair added to that a little bit, which he estimated that it wasn't going to be 1 or 2. So he went straight to 4 and got it right. Now, he might have gone to 5, and it was too big, and he would have gone down 1. Now, Eden's reflection on her approach was that the difference between 4,500 and 5,469 is not that big, so she could probably start at and just go up all of them. It wouldn't take that long. Yeah.
I suppose if it was, let's say N was, 12,469. Then, Alistair could have still followed this method.
Well, I would have definitely done either of that.
Yeah. People are still guessed.
So, yeah, I mean, if it was like 12,634, that's a big jump. So we would have gone for N equal, I don't know, 7 maybe. And then that might have not been anywhere near, then another jump. Once I'm close, I just here. All right, another slightly different version of the question, guys. All right. This time, do you remember going back to the sequence rule that we had? Do you remember it was called an explicit formula? So we've got the rule. This time we've been given it. All right. So it says Bill invests £500 on the 1st of January at a compound interest rate of R% per annum. So this time it's not telling us the R, not in the writing. It says B, the value, okay, of his investment, so it started at 500. After a certain number of years, N is given by this formula. What is R? So R is the interest rate. Anyone remember how to go about doing that? Or knows the thing?
Just, I mean, it's maybe wrong, but 500 times 1.04. And then year.
An answer.
Yeah.
Okay.
And then we find what the
So year 0 is 500. Year 1 is?
But what year 0 be 2000?
No, so year 0 is how much he invested. That's the 500. How much was his investment worth after 1 year? So when N equals 1. So we would do 500 times 1.045 to the power of 1. What do you get? Five hundred and
22.
22.5. So, let me ask you this. I've got this number, I've got this number. The interest rate is what you do to get from one to the next, yeah? What do we multiply by? That's the R, yeah? So, what do you think, Sienna? No. Compound interest is multiplying. Simple interest is adding. So in this case, what we're looking at is every time, what do we multiply by? Do you know, next one.
Oh, 0.0.
Well, we don't. We multiply by 1.045. Yeah? How can I see that from the formula?
It's
Do you remember we did that before? Do you remember I said UN equals, and we had A R to the power of N minus 1? And do you remember we kind of looked at it and went, if I said UN equals 3 times 2 to the power of N, what was the common ratio? And we said R is 2. And it was easy to spot that. Now, this is exactly the same, look. This is UN equals A times R to the power of N. So, what we multiply is this. All we've actually got to do is figure out what does that mean in terms of an interest rate. It would be 4.5%.
Technically, at the very beginning, where it tells you 1.025, you can guess that.
Well, we don't need it, it's there.
Yeah.
If you understand that that's the way the setup is. It's not. Now, what we did before, guys, do you remember, it's like, before we realised that, we went, well, if I've got 500 and I've got 502, we did 522.5 divided by 500, and we know the answer is going to be 1.045. Which we then went, oh, but that's already there. Do you remember going through that lesson? Yeah. So the only difference is you have to interpret it's not 1.045%. Okay? So this is important, this is a very important bit. This bit, it's not 1.045%. It is 4.5%.
But that's what R included.
That's what R as the rating is. Yeah, so R, big R,
I said that
Not
on
in that.
jump. I said that on
yes.
Can you explain that?
This was what we did, that's geometric. If you remember back to when we were doing geometric sequences. And remember how all this came about? We said one of the geometric sequences was compound interest, and we were going to apply the formula for geometric sequences, but in a compound interest context. And that led us to the fact that no one knew what compound interest was. Hence, we're doing it in this way.
Now, is that, we use that finding the one.
Well, I didn't use this. I've got my knowledge of the fact that that is a geometric sequence.
Yeah.
I know that compound interest, we've already identified compound interest is a times sparse, that's what we're talking about, which we know gives me a geometric sequence. So because I've identified that, I know this is the formula, and then I'm also told that is also, they give me that, so then I can go, well, this formula and that formula share structure. So this 500 is my A, okay, my first term, and this is the R, the 1.05, 0.5. Now, one thing for everyone to realise, ladies and gents, do you remember what there's one important difference between a financial situation and just a geometric sequence? So this is year 0, but if it was just a geometric sequence, it would be year 1. So at the end of year 1, it would actually be U2. So that's the difference. This is why this is n minus 1, but this is just n. Alright? So there is a slight difference because you are applying it to a real world context. Alright. Hopefully, you can now apply everything we've just done. How much is Bill's investment after 20 years?
That's the same as like the other one.
Exactly the same as we've been doing before. Exactly that.
Right?
It's not even backwards, this one. What have we got? We've got a formula which is. So I would write down my formula which is.
No, it's talking.
You took that previous one.
I'm talking about. Go back up.
Well, I'm just going to write this. That's my formula. And I want to know after 20 years is n equals 20. What's your.
I'm just saying, like, So 1.045.
From that to that.
Yeah,
It's backwards from
Yeah.
one. Yeah, that little bit. So again, we've got a formula. We don't even need to work our own out. We could just apply it. But what we're thinking about is 500 is year 0. Year 1 is, year 2 is, year 3, all the way up to year 20. We're not going to do it this way, are we? Because that would just use all my time. So we're going to do, the value is 500.
0.045 to the power of 20.
That's why it says. Yeah.
Is that it? Doesn't use regular calculators or
It's actually